Hello, Honors Algebra 2 students. We're going to have some fun today. We're going to graph some trig functions, take all of your knowledge of the unit circle, sine and cosine, and it'll be a great day of graphing some simple functions. And graphing these is something you will use in real life. They happen all over. These waves, you can see them in your heartbeat and all sorts of things. Once you see a couple of our graphs, you'll be able to relate them to your real life. We're going to start with graphing cosine of x, and I think we'll even start a little bit simpler than this table in radians. We'll go with degrees, and we'll do x and y, and we'll make cosine 0, 90, 180, 270, and 360. So if you look over here at 0 degrees, cosine we know is the x value. So the cosine of 0 degrees is 1. The cosine of 90 degrees is 0. The cosine of 180 degrees is negative 1. 270, we're back to 0. And 360, we're back to 1. So you can see that a cosine graph, if you went from 0, 90, 180, 270, 360, is going to look something like this when I plot the points. And you can see that it's got a nice repeating pattern, and it's cyclical, and it has a length of time that it takes before it goes all over again. So if we kept going, just kept going around our unit circle, we just keep making this wave. And now we're going to fill in this chart, and we're going to go around that unit circle and get the cosine values in radians. So again, I know you guys remember this, that cosine on the unit circle goes with the x-coordinate. So when we're looking at x comma y, we're going to go around that unit circle and look for the x-coordinate. We'll take a better look at our unit circle, and we'll go around. Cosine of 0, we'll start right here, is 1. Pi over 2 is the same as 90 degrees. I've got an x up there. 0. You come over here to pi, x is negative 1. You come down here to 3 pi over 2, x is 0. Come back all the way around to 2 pi, and you're back to 1. We could go around and see it on the other side as well, and you're going to see the repeating pattern. But here's the table filled out. And you can see it's a bunch of zeros and ones and negative ones. I am going to graph from 0 to 2 pi here, so you can take a look at the wave. So we'll go over 0, up 1. We'll go over half of pi, which would be 2 spaces, and up 0. We'll go over to pi, and we'll go down to negative 1. We'll go over to 1.5 pi, we're back at 0, and 2 pi will go up to 1. We connect these, we try to roll it around. It's very smooth and perfect. It's a beautiful wave. And that is called one cycle or one period of the cosine wave. Now, if I do the other side, you'll get to see it again. If I come over here to negative pi over 2, negative 1/2 pi, I'm back at 0. Negative pi is negative 1. Negative 1.5 pi is 0. And negative 2 pi is 1. So you can kind of see how this really, you could put arrows on the end, it goes on forever, and it's just a nice smooth wave. And you'll want to look at some properties of the cosine wave. Right now I'm sure it looks a little confusing to you, but as we graph many of them, you'll see some characteristics and things where you can shortcut them in. Just like when you learn to graph lines and find shortcuts, you'll do that with sine and cosine. So now here's a sine wave. Again, I could go around and do it in degrees for you, but I'm going to go right to radians since we already did that in degrees with cosine. But if you wanted to, if it would help you, go around in increments of 90 degrees. And you could see an x and a y, and you could plot a graph. I'm going to go to radians, and I'm just going to do one side again. So you guys remember that sine goes with the y coordinate. Again, we're looking at x comma y. Sine is going to be the y. So the sine of 0 is 0. That's one difference. Sine goes through the origin. When you get to pi over 2 or 90 degrees, sine is up here at 1. When you come around to pi, sine is back to 0 already. When you get down here to 3 pi over 2, it's negative 1, and back to 2 pi is 0. 0, 1, 0, negative 1, 0. So you can see it repeats, and it's got patterns again. We could go back around this way. Remember, negative terms would go down, and our y value of negative pi over 2 is negative 1. We come around here to negative 180, sine is 0. Come up here, it's 1, and it's 0. So we'll give you the completed table right here. And I'm going to graph one period or one cycle here. Again, I'm going to start and keep things positive. Notice sine goes through 0, 0. Cosine did not. You go over a half of pi, and now you're up 1. You go to pi, and you're at 0. You go to 1.5 pi, you're down to negative 1, and 2 pi is 0. So if this confuses you, all I'm doing is writing all of these as ordered pairs. This is 0, 0, x and y. This is pi over 2, comma, 1. So I went over pi over 2, up 1. So all of those numbers off the table. And you can see the sine wave looks a lot like the cosine wave. In fact, we could find a cosine wave in there, and we'll talk about that in a little bit. If I graph the other side, negative pi over 2 is down to negative 1. Negative pi is 0. Negative 3 over pi over 2 is 1. Once you do enough of these, you can kind of see how it rolls. Again, you could put arrows on it. It's a good idea to know that it goes on forever, and it is cyclical and has all those properties. So what I would like you to do is practice graphing some sine and cosine waves. Just get good at them and make an x and y axis. Sine always starts at 0, 0. When you get to pi, you are back to 0. When you get to 2 pi, you are at 0. And in between those, sine goes up and then comes down. There's a sine wave. Practice making that over and over again. This is called one period of the sine wave. There's arrows on it, it goes on. We're going to talk about how high it goes and how long it goes. We're going to stretch it out, shrink it up, make it go higher and lower, and mess around with that. Cosine is just a little bit differently. And again, if you just deal with the positives, I think that'll help you. Cosine starts at 0, 1. So you'll see it right here. But then it has a lot of the properties of sine. So sine started at 0, 0. So cosine starts at 0, 1. And then when you go out here to 2 pi, you're back to where you started because you've gone 360 degrees. At 1 pi, it is down below the x-axis. And halfway in between is where it crosses the x-axis. And there's your cosine wave. Now, I'll bet you see some properties and similarities, but practice making even these simple little graphs so you get an idea of what it looks like. Notice the cosine wave crosses the x-axis twice. The sine wave crosses the x-axis 3 times in one period, or one cycle. And just for those of you that are interested, I'll bet you, so here is cosine x. Watch this. If I trace this in red, doesn't that look like a sine wave? It just didn't start at 0, 0, but if I shifted it over here, it made that 0, 0. And then come up here, doesn't this look like a cosine wave? Kind of starts above 0, 0, and it comes down through. So if you messed around about shifting it, you get a good idea of what it looks like. I love the sine and cosine waves. And once you practice them, you're going to be awesome at it. Here they are again with a couple of things you can put in your notes. The domain and the range, some vocabulary words here. The domain, you guys, is all real numbers. And I like to write it like that because I'm lazy. You can choose any value for x. There's no value for x that you can't get. Right now, the range, if you noticed, for all of your y values in the table, it was from 0, not from 0 to 1, from negative 1 to 1. And if you want to write that mathematically, you write it like that. Y is in between negative 1 and 1. The period is 360 degrees. We like to use radians, so we use 2 pi, the period of both functions. That means that's when it starts over again. I am going to trace the sine wave here in red. Starts at 0, 0. When you get to the end of your period, it's back to 0, 0. Halfway in between, it crosses the x-axis, and then what goes up must come down. Want me to sing that song for you? What goes up? No, I won't keep going. There is a sine wave. Cosine, I'm going to do over here in green. Notice it started at 0, 1. When you go over 2 pi, it is back up to that same height. Halfway in between, it's down low. And if you think and remember that these waves are symmetric and beautiful and perfect, then you'll know it's got to cross that x-axis in between. And there is one period or one cycle of the cosine wave. And again, I'm trying to keep it simple, keeping it into kind of the positive side of things. We can graph lots and lots of different periods and keep it going. All right, so on this page, what I was going to do is have you practice one more time. Here is a sine wave. Go ahead and practice it in your notes. Where does it start? 0, 0. Where does it end? 2 pi. It's back at 0, 0. What's it do halfway in between? It's at 0. So those are what we call critical points or critical values. And then if you picture the wave we've been practicing, it goes up before it comes down. So that means at a half pi, it's up 1. At 1.5 pi, it's down to -1. And you can see if we put arrows on it, the domain is all real numbers, x goes everywhere. In the range, it goes from -1 to 1. Now I'm going to switch colors, and we'll put a cosine graph over here, and we'll practice that. Now cosine does not start at 0, 0. It starts at 0, 1. And its period is the same, so when you go out to 2 pi, you're at 2 pi, comma 1. Now, this is where it's a little bit different. Halfway in between, it goes low, and the lowest value is -1. And then think about the pretty picture of your wave and roll it through. That means halfway in between here, it's got to cross the x-axis, and it's got to come back up. You put your arrows on it. You can see the domain, again, is all real numbers. It goes on forever in the x direction. And the range, you can see pretty clearly, again, is from -1 to 1. So all we're going to do now, everybody, is we're going to switch that how high and low it goes, and we're going to switch how tight the wave is, or we're going to stretch the wave out. And if you think back to chapter 3, which was a long time ago, it's kind of like dilating things. They have a few little different names. All right, here's some more things to put in your notes. This is the general form for a sine function. Notice I was writing y equals sine x. Well, in that's the parent function. A is 1, b is 1. There's really a 1 here and a 1 here. Same thing with cosine x. When we've been writing that, that's your parent function. A is 1, b is 1. So A is going to represent the amplitude from now on. That's going to be the amount the thing goes above and below the x-axis. We can also make it -A and flip it. So the amplitude is the absolute value of A. The frequency is the number of cycles that occur in 2 pi, and it's the absolute value of B. Notice it even goes alphabetically, so that's going to represent your amplitude. That's going to represent your frequency. And to find out how long the period should cover, there is a formula, 2 pi over B. This is the big one you're going to want to remember. Period is 2 pi over B, because we will usually ask you to graph 1 or 2 periods of the function. All right, here's our first example to put in your notes, and we're going to do a cosine function. So I'm going to try to graph it without making a table of values and just use some shortcut values. So if we take a look at our equation, it's y equals A cosine bx, and A and B help us out. The frequency is B. Well, in this case, B is 1. It's the number in front of the x. There is no number there, so it's 1 times x. The amplitude is A, and that's easy to find. It's the first number. This one only has an amplitude of 1/2. The period, remember, is 2 pi over B. In this case, it would be 2 pi over 1, which is 2 pi. So now I'm going to go and try to remember my practice of the cosine graph. It does not start at 0, 0. It starts at 0 amplitude, if that makes sense. So I'm going to start at 0, 1/2. Notice in the parent function, it was over 0, up 1. Now I go to the end of the period. 2 pi, it's up that same 1/2. In between now, I got to picture this wave. It's beautiful and symmetric. At pi, it's going to be down 1/2. And then halfway in between, these are the x-intercepts. Half pi 0, 1.5 pi 0. Be nice if you could print some graph paper that had trig functions on it like this. Otherwise, you'll have to just renumber your graph and scale it like this. And here's one period of your graph. Notice it looks a lot like the parent function. I'm going to put the parent function on top of this one just so you see it. Cosine starts at 0, 1, ends at 2 pi 1. Halfway in between, it's at pi negative 1. This would have been your parent function. They're very similar. The only difference was that 1/2. So you can always pause these videos and slow them down, but there's your cosine graph. Now you can see we're going to change b. So remember, our equation goes like this. A is the amplitude, and in this case, A is 1. 1 times the cosine of 4x. So if you don't see a number in there, it's 1. The frequency is b, so in this case it's 4. That means we're going to see 4 cycles in that 2 pi period. Now the formula for period is 2 pi over b, which in this case would be 2 pi over 4, which would be pi over 2, or 1/2 pi. Okay? We're going to slow this one down a little bit because I think changing the frequency gives people a little bit more trouble than changing the amplitude. So notice again, we're on our cosine function. If it helps, the parent function looks like that. Gives you a little idea of one period. So I'm going to have an amplitude of 1, so I'm going to start at 0, 1. Now here's the big change for this problem. I've been used to going to 2 pi, but now my period is 1/2 pi. So when I go to 1/2 pi, I shrink or condense my wave. So this is one period now. So instead of going out to 2 pi, I go to 1/2 pi, and remember, it stays at that same height. Now what does it do in the middle? In the middle, it goes to its lowest point. And in this case, the amplitude is 1. Remember, it is symmetric, so if it's 1 above the x-axis, it's 1 below the x-axis. And then halfway in between, we're going to get our x-intercepts. Try to graph 5 critical points, we call them. 5 main points to get one period. So look at this graph. That's one period. So it really was shrunk or condensed. I just want you to see what this frequency means because a lot of people ask about it. Every 1/2 pi, so it's going to go, here would be another wave of it. It would come down here. So I'll do this one in green. Ooh, what did I do? Back up. We're just going to go 1/2 pi. Yep, I did goof it up. We go up high. And we're going to come down low. Here we go. There would be a second period. If I kept that going and went out 1/2 pi, in between, you could see 3. So this is 1 cycle, 2 cycles, 3 cycles. We've got 1 color left here. If I go out here, you can see what the 4 means a little bit. The 4 represents how many waves there are in a normal 2 pi period. So you can kind of see that there are 4 waves in there. And this black one is all you would graph if you had to graph 1 period or 1 cycle, but I wanted you to see all 4 of them. All right, so I'm going to do a cosine one more time. Here's the parent. Where does it start, everybody? 0, 1. If it has a normal period of 2 pi, it ends at 2 pi 1. Halfway in between, it goes down to negative. So those are 3 big points. If you can picture the wave now, you know your x-intercepts are halfway in between. So this would be 1/2 pi, 0. And this would be 1.5 pi, 0. Again, practice that cosine wave. The more you practice, the better you'll get at it. And then remember what we do. Making it go higher and lower is a piece of cake. The stretching it is what takes some practice. And what stretches it is the B. What makes it go higher and lower is the A. All right, here's another cosine. Now we've got both things going on. Can you handle it? I know you can. Y equals A cosine B x. A is the amplitude. This one, a little fun, we get to go up 4. B is the frequency, 1/2 this time. So you're only going to see half of a wave. The period formula, remember, is 2 pi over b, 2 pi over 1/2. To divide two fractions, my, flip the second and multiply. If you flip the half, you get 2. 2 times 2, it is 4 pi. All right, so we'll slowly go through this one. Where does cosine start? It starts at 0, 4 this time. Remember, it's 0 the amplitude. Parent function would be 0, 1. This goes up to 0, 4. Now, I go to the end of the period, which is 4 pi. You can't see it. I'm just going to pretend it's out here and put a spot way out here. But at 4 pi, it would be back up 4. I'm going to write that a little bit neater because it's pretty sloppy. But if you went out to the end of the period, you'd be back up. Let's pretend that's 4 pi. Now, what does it do halfway in between there? That would be to 2 pi. It's going to be down 4. So if you can picture this thing, notice in a 2 pi period, we're only seeing half of a wave. That's what that frequency means. So at 3 pi, which would be right about here, we'd have 0. I just want you to be able to picture it. At 1 pi, we'd have 0. So you can see my 5 critical points. Only 3 of them show up on this graph. If you wanted to see the rest, that's kind of a bad thing. But on your graph, on a quiz or a test, you would get that much of it. You'd only be showing us 1/2 of a wave. All right, I hope you had fun with cosine. You can guess what's next, sine. So before we start, I'm going to sketch the parent function. Sine starts at 0, 0. Sine ends up at 2 pi 0. And it is in the middle, it's at 0. So it's a lot like your Honors Algebra 2 teacher. It's a bunch of zeros. Yeah, funny. Sine has a wave, though. It goes up and down. There's what it looks like. That's our parent function. This one, A is 3, B is 1. That means the period is 2 pi over 1, which is 2 pi. So if you need this again, A is amplitude, B is frequency, period is 2 pi over B. So this one we're just going to make it go higher. So it still goes through 0, 0, still goes through 2 pi 0. I think sine is a little bit easier than cosine, and it still goes through pi 0. Sine has 3 x-intercepts. Now halfway in between, you're going to go up to 3. Halfway in between, you're going to go down 3. There is one cycle or one period of the sine. Try to make your waves smooth, everyone. Don't make them like they're lines. They don't have slope. They have curves. And it is symmetric and beautiful, like I said. Try to make your pictures as pretty as you can. All right, let's switch up the frequency. So remember, A sine Bx, A is the amplitude, and this one, the amplitude is 1. 1 times the sine of 4x. B is the frequency, it's 4. So now, you're going to see 4 waves kind of tight together again. Period is 2 pi over B. 2 pi over 4 reduces to a 1/2 pi. You can write that as a 1/2 pi. This gets confusing for some people too. Pi over 2 is the same thing. All right, so this one's going to be kind of fun, but sine starts at 0, 0, always. And now you go to the end of the period. So when I go to pi over 2, I do not go way out here. The frequency changed. I need to get 4 waves, so I need to bring it right here, pi over 2. And then halfway in between there is a third x-intercept. Remember, sine starts at 0, ends at 0. 0 in the middle. And now it goes up and down, and this is going to go up 1. The amplitude did not change. That would be 1 period or 1 cycle. If you wanted to see all 4 of them, here would be the second one. See the same thing, we can keep switching colors. It's easier than cosine because it just keeps going up and down. There's the third one, and what do I have left here? Here's the fourth one. So that's what the frequency means. In a normal 2 pi period, you see 4 waves, red, green, blue, and black. And the amplitude is still 1 above and 1 below. All right, hope you're having fun with sine and cosine. We're gonna whip through a couple of signs here. Remember, the first number you see is A, amplitude is 2, second number is B, and the frequency is a fourth. If you remember what I've said way back in chapter 3, fractions make you fat. We are going to widen out or fatten this graph. The period is still 2 pi over B, and 2 pi over a fourth. You've got to use your fraction skills. 2 times 4 is 8 pi. I should probably change this scale, but I'm just going to leave it so you can see that you're going to get a really wide wave. So sine starts at 0, 0. In this one, it would go way out. You can't even see it, to 8 pi 0. And it would be at 4 pi 0. Remember, it has 3 x-intercepts. So that means at 2 pi, it's going to be up to its amplitude, which would be 2. That's all you're going to see of this wave. So it would go from here to here. When you got to 4 pi would be your next x-intercept, 6 pi you would be down 2, 8 pi you would be up 1. So if I changed my grid, and I went 0, and I put 8 pi way out here, these would be my 3 x-intercepts. And at 2 pi, then it would be up 2, and 6 pi it would be down 2. So you could do that too. It's just if you're using consistent graph paper. When we had tests and all that stuff, we would supply the graph and we would have it numbered for you. Here's another cosine. Here's another sine, another cosine, another sine. I think we're going to, actually, let's do one more sine and then